and welcome to this building science presentation hosted by Owens Corning. I'm Adam Cohen, and I'm here to talk today about integrated delivery of passive house buildings and a market rate approach to high performance construction. I hope you enjoy the lecture. All right. Thank you, and it's really great for me to come here and meet you guys all in person. I've gotten to know Achilles through the WWOOFy stuff, but also I'm vice chair of the technical committee of the Passivhaus US, and the Passivhaus Technical Committee is a volunteer organization, and we were lucky enough to get Achilles to volunteer. And I want to thank Owens Corning for supporting our work in the technical committee, because having Achilles and his team helping us through the technical issues on this volunteer committee has been really great. And I believe Owens Corning also helped us with development of the WWOOFy passive software, which is kind of state-of-the-art modeling software. So I want to thank you guys here at Owens Corning for doing your part in helping move this forward. So what I want to talk about today, just fairly straightforward, is how we have been able to deliver buildings that are high performance, meaning using 60 to 70% less overall energy, 80 to 90% less heating and cooling energy at market rate. Okay, we can all deliver buildings that are very high performance, that are boutique, right? If people know what the Bullitt Center is out in Seattle, it's a living building challenge building, wonderful example of a high performance building, but something that's not repeatable because it's so darn expensive. And so what I have done is to kind of crack a barrier, and I'm not alone in this. And what I want to talk about today is how we've been able to produce tomorrow's buildings today with no premium cost. And I think that's a really important thing, because typically high performance always in the past comes with a premium. So that's me. Okay, so who am I? This guy that's talking to you guys. So I'm the guy that in high school was reading Ken Kern, you know, the Back to the Land movement in the 70s. Somebody's smiling over there who knows what who he is. I also was intrigued with Gaudi, and I went to Barcelona to check it out. In architecture school, I drove my professors crazy because I thought Malcolm Wells was, you know, the earth-sheltered person from Massachusetts was like a king, and everybody in my architecture school was doing postmodern blah, blah, blah. And so I got in lots of trouble for doing things like designing underground churches when everybody else was designing little things with schnutzies all over them. And then, you know, Fry Otto, Eros Saarinen, these are all and Michael Reynolds, Earthship, these were all heroes of mine. And so, you know, there I was in the late 70s, early 80s, and you go, God, this is kind of weird stuff. Why is that all together? Well, when I grow up, I want to be a sculptor. And unfortunately, when I was going to school, my dad said that he wouldn't help me with my tuition if I went into art school. So I was like, well, architecture, art, they're kind of close. So I'm still trying to be a sculptor when I grow up. So I graduated from University of Maryland School of Architecture 30 years ago, immediately left and started building off-grid, what I called healthy homes. No glues, no chemicals, 100% healthy homes. I thought 10 years from now, everybody's going to be doing this, right? I just thought it was natural to be doing it. But 10 years later, I had a family of 5, no money, and very few people that could actually pay me to do it. So I started doing other things, eventually winding up starting Structures Design Build, which is a design build firm, where we focus on high-end residential, light commercial. And 2006 or so, I started getting a feeling like I had really sold out. We had a very successful company, you know, knock on wood, but I had kind of lost my roots of high performance, and I started looking around because I wanted to go back into it, and I discovered the Passive House methodology. The Passive House methodology grew out of the super insulation movement here in the 70s and 80s. But when I discovered it, I was super turned on. I said, wow, they actually figured it out. Now, I was one of the guys who in the early 80s built high performance, super insulated. And I also was one of those people who 2 years later went back and fixed all the melting stuff that I had caused, right? Because I didn't understand the building physics. I threw that out and I said, okay, forget it. I'm not gonna do that anymore. That cost me too much money. But when I started reading about Passivhaus, I said, wow, they actually sat down and figured it out. And so here's some of our projects. We did the first Passivhaus school. This is a LEED Platinum school. It's a demonstration project, 3,600 square feet. And it's not just Passivhaus. It's an amazing building. It's an energy positive building that has just about every sustainable bell and whistle you could put in it. This is the first assembly building in the United States. This is the Malcolm Rosenberg Center for Jewish Studies at Virginia Tech. That's a dental clinic, 5,000 square foot dental clinic that we did last year, completed last year. And this is Hickory Hall Dormitory, 40,000 square feet. Right now, that's the largest passive house building in the U.S. So and all those were delivered for market rate. We're going to talk about those later. But about 2.5 years ago, I started getting calls from people wanting to know, how are you doing this? So I started a company called Passive Science, and I've been consulting on large-scale passive house projects around the country. So here's just some examples of some of the commercial work. So one of the things I realized very quickly was that commercial passive house was super easy because of the passive house is basically a fabric-first approach where we're attacking the envelope first. And when you're looking at single-family homes, that's the worst thing to do, right? Because there's the volume to skin ratio is horrible. But then you go to a commercial building, and all of a sudden, this volume to skim ratio gets to where, on some of these projects, it's actually cheaper to build a passive house than standard construction. So let's talk about it. What is this passive house thing I'm talking about, right? It is definitely not a 1970s passive solar house, right? Because we say passive house in the United States, and what do we immediately think of? We immediately think of a roof line that looks like this, and a big wall of glass, and maybe a stone trom wall behind it. That's absolutely the wrong thing. The worst thing about passive house is the name, because in German, when they hear passive house, they think passive as in non-active, and house as in building. It would be a Hof if it was a house. But a passive house to a German is a building that needs no heat. A passive house to American is a 1970s passive solar house. And so where did it come from? According to Wikipedia, it's a rigorous voluntary standard for energy efficiency. Passive House Institute US says it's today's highest energy efficiency standard. Passive House Institute, which is the international institute, it's a building standard, energy standard that's energy efficient, comfortable, and affordable. That's a key here of where I'm going with this. It's not a brand name, but it's just tried and true concept, and it can be applied anywhere by anyone. All you have to do is understand it. A better term in North America, I think, at this point is passive building. So that's what I'm going to use. So the history, based on our experience, in the 1970s, for those of you old enough to remember 1973, Yom Kippur War, and the gas shortages, all of a sudden we started saying, well, maybe if our cars are using a lot of energy, maybe our houses are too. And so as a culture, we sort of reacted to that and started creating some pretty impressive stuff. I mean, we look back down to 1974 at this University of Illinois Small Homes Council home. We look at this now and it doesn't seem like anything special, but things like insulated panes in the glass, proper overhang siding, insulation, air sealing, these were all things that were kind of new. This next house here, the Saskatchewan Conservation House, was done in the mid-70s, and this is the first house that actually proved the concept of heat recovery ventilation and not needing a conventional furnace for a project. The National Affordable Housing Network, centered in Montana, you can still go online and buy these plans from the 70s. They're high-performance houses. $100 buys you that plan online. Eugene Ledger was just a building geek like me, who decided in the early 80s he was going to build a low-energy house and heat it with his hot water heater. This is in Massachusetts. And then Canada had the R2000 program, which really worked to try to push the envelope forward in terms of building products and creating products for higher performance. In 1979, there was a groundbreaking press release that came out, and this is really interesting. This guy, William Sircliffe, was an MIT professor, and in '79 he put out a press release that described his vision of high performance. So truly superb insulation, not just thick but clever and thorough. The envelope of the house is particularly airtight. There's no provision for heavy mass. You don't need a lot of thermal mass to make these buildings work. And this is very contrary to what we were doing in the 70s. No provision for extra large south windows, right? That old 1970s bright big south glazing. Absolutely nothing like that. Passive house is about balance. It's about energy balance. It's not about overpowering. It's a very is a very powerful way to really look at the performance of a building. There's no conventional furnace, just steal a little heat from the domestic hot water. No conventional distribution system, because by working on a fabric-first approach, you're limiting the delta between any surface, including window surfaces. So you get rid of the convective loops that start building up in a building when you have greatly different temperatures of our surfaces, or something called a mean radiant temperature. I'm sure most of you guys know what that is. And in a passive house, the mean radiant temperature is just cozy, and you end up not having that convective loop needed. The heat kind of goes where it's supposed to. You don't have to do anything weird. Nothing has to be shaped weird. No weird architecture. Can look exactly like everything else. No added expense. Once again, he's right here at the affordability. The passive solar heating is very modest and almost incidental. That's absolutely true to a passive house concept. And the room humidity remains near 50%. And we're finding that in the monitored results of our projects. We are staying 40 to 60% range all year long. And then if you do it smart with your cross ventilation and your night cooling, if you're in the proper climate, you can get away with virtually no cooling. So what happened? What happened was that a lot of us, like me, jumped in and said, "Oh, super insulation, what a great idea. I'm going to go super insulate. I'm going to make a double envelope house. I'm going to do all kinds of things that we never did the building science for." And, you know, we were getting phone calls like this, you know, a year and a half later. Adam, I really love my house, but I'm getting this weird smell, right? And that was always like the worst thing. And then you're under there cleaning with Clorox and pulling stuff out that you didn't know, and you didn't really think through the building science. And the Germans looked at what we were doing and said, you know, these Americans are cowboys. They go out and they build without thinking. Germans like to think, right? So these two guys, Wolfgang Weiss and Bo Edmondson, he's a Swede, he's a German, they spent 5 years saying this should work. We know the physics should work. So they calculated and figured and came up with an idea of how to build a building that would be optimized for cost and for low energy. 1990, they built their first building. It's a 4-unit passive house. Now, you got to keep in mind that in 1990, we didn't have triple glazed high-performance windows. We didn't have highly efficient energy recovery ventilators or heating recovery ventilators. There were a lot of things that they didn't have they had to make up, kind of MacGyver it all together. But this building ended up with a 60 to 70% energy reduction overall and 90 to 95% in heating and cooling. And they founded the Passivhaus Institute in 1996. Now, since 1996, there's over 40,000 projects completed in Europe. In 2009, well, let me back up. After the Kyoto Protocol was signed, Europe really made a huge commitment to lower their greenhouse gas and their carbon footprint. And when they did that, just like here, they looked and they said, you know, over 40% of our greenhouse gases are caused by our buildings. And they looked deeper into the numbers. They said, well, you know, 95% of that is the operations and maintenance. So we need a way to tackle the operations and maintenance of our buildings and lower the energy. They spent millions of euros studying different methodologies for low energy. And in 2009, the EU actually put out a directive that directed that all states adopt the passive house level of performance by the year 2018 for all buildings. There are already a bunch of countries that have adopted it and more that are coming. So it's well proven. And the important thing is that the reason they pointed to for that metric was that it was repeatable, it was verifiable, and was affordable. And once again, that affordable word comes in. So passive building. Let's talk about the definition. What does it mean? What is it exactly? The original definition as conceived by the Passive House Institute in 1996 was a building that could be conditioned only through the fresh air required, right? So we're making a very airtight envelope, right? Because we all know 30 to 50% of our energy use is through infiltration, exfiltration through the envelope. So the first thing you do is you cut off that waste of energy. What did I do? Well, sorry about that. Let's see. There we go. But then, right, how many, everybody here probably gets, I get sick of hearing, well, buildings need to breathe, right? Buildings don't need to breathe. People need to breathe, right? A building is absolutely fine being airtight and sitting there all day long airtight as long as there's no people in it. As soon as you put people in it, they're the ones that need to breathe, so they need to breathe, right? So the idea was you're going to bring in fresh filtered fresh air, you're going to put it through a heat exchanger so you're not wasting the energy that you've created, and then exhaust the stale air. Well, that amount of air that you need for hygienic air exchange, if you could deliver just that amount of heat that's coming through that fresh air, or that amount of cooling that's coming through that fresh air, all of a sudden that makes a perfect kind of a way to make it an affordable way to deliver your conditioning. That was the first concept in the Passivhaus Institute, that if we got less than 1 watt per square meter, we could pretty much deliver heating through the conditioning system, and we could do this based on a German concept of conditioning. Okay, now the Germans, because they were pushing this forward, their concept of hygienic air exchange is 0.5 or 0.3 air changes an hour of the volume, right? So that's the amount of heat that they want to deliver. Now the Norwegians say, no, you need 0.5. Why? Because the Norwegians, I guess, like healthier outside air, right? So the Norwegians say, no, you need 0.5, so they can deliver a little more. The bottom line is the original concept was to deliver it at this 0.3, this German idea. What they found in practicality was they had a hard time meeting that number in the climate of Northern Europe, so they slightly modified it. Now you can still make a passive house by definition by delivering through the ventilation air, but what they found was that was a tough metric to make, so they loosened it a hair, and they basically made 3 metrics. You have the annual heating demand, annual cooling demand, and that's 15 kilowatt hours per square meter, total demand for heating or cooling. The total primary energy is 120 kilowatt hours per square meter. Now that number is primary energy. That is what is produced at the energy plant, right? So here in America, we need to divide that by 3 because of the waste coming from our coal grid. Our primary energy factor in America is about 3.1. So we get about 40 kilowatt hours per square meter. You know, and if you want to take it down to kilowatt hours per square foot, that's about 4 is what we're ending up with. And then air leakage. The net air leakage here at 50 pascals pressurized and depressurized is 0.6 air changes. This is a test to the envelope. Okay? Now what you got to understand is when we're designing these buildings, right, we're using a methodology that is looking comprehensively at everything within the building, right? We always talk about building as a system, building as a system. Well, this really gets at building as a system. But in order to really look at it as a system, you have to make sure that all the components of the system are built as designed. So one of the very, very, very important things about Passivhaus is to make sure that you commission your envelope. If I commission the air tightness of my envelope, if I do thermal imaging and commission the continuity of the insulation, I can guarantee to the mechanical engineer what my leakage rate, my exfiltration and infiltration rate is, what my U value are, so that their mechanical system can be optimized for that particular design. They're not guessing how bad are we going to build our building, how leaky is it really going to be in the field. So we're able to actually design systems so that they work at their peak efficiency, rather than over-design them, so they cost more up front. They short cycle because they're not on long enough, because they're oversized, because we didn't know how bad it was going to be. And then the mechanical equipment doesn't last as long. So it's running less efficiently. We paid more up front. It's running less efficiently, and we have to replace it more often. So this is actually, if you look at in terms of life cycle cost, it's a really intelligent way to be approaching a building. And what it does in North America is it makes us rethink how we are creating our envelopes, because we are not used to commissioning our envelopes. We just, as a rule, have not done it. So how do we achieve those kind of metrics? It's fairly simple. You minimize the losses through the envelope, right? So it's fabric first. We want to increase our insulation levels, create an airtight construction, get rid of our thermal bridges within the envelope. The really interesting thing is as you start to lower your energy use as greatly as we do, what used to be thermal bridges in a typical construction, it's no big deal. It's a tiny, tiny, tiny little part of the load, right? But when you start looking at a building that's dropped its heating demand by 90%, all of a sudden those little thermal bridges can be 10, 15% of the load. You know, before it was negligible, who cares? The other thing it does by looking at our thermal bridges is we eliminate the cold spots on the interior walls. We not only analyze them for the energy use, but we're also analyzing them for the minimum interior surface temperature so that we have no chance of condensation on the inside. Then we maximize and balance our gains. And this is absolutely true. It has to be a balance. Some of the early passive house folks here in the US, the younger folks who hadn't done passive solar like some of us older fellows had, were overglazing their buildings and they were ending up with overheating. Why? Because they hadn't learned that lesson, right? We learned that lesson back in the 80s. So you were using high performance glazing, shading, passive ventilation, and then we're accurately calculating our interior gains to make sure we can take advantage of them. And then lastly, the last piece of the pie is using a very efficient system. So fresh air and heat recovery, high performance mechanical equipment, and then high efficiency miscellaneous electrical, so lighting appliances. So I'll add that all together and you get these low energy buildings. So is it really different? Is it really different from what we do? It's not. It's no different. I'm a design builder. So for 30 years, I've been an architect and a builder, right? Also an energy geek and a building nerd. And so what I can tell you is that, you know, I've run around for years telling everybody, oh, design build, it's the best thing to do, and usually got looked at pretty weird. But now, what I've been doing for 30 years has a really cool name. It's called Integrated Project Delivery and Lean Construction. I didn't even know I was doing this, but that's what it is. That's the buzzword now. So in the last 5 years, I've been able to talk about what I've been doing for 30 years, but in a way that other people go, ooh, that's pretty cool, instead of you're the crazy energy guy running around for 30 years. So what's different about what we're doing right now is that the process changes the product. It's the process of design and construction that's actually changing, not the design and construction itself. So in design, right, we are looking at the building holistically, right? And we're looking within the guts of the system to find symbioses between aspects of it so that we're able to make not only energy savings, but cost savings, right? So as a design builder, it's really easy for me as an architect, a builder, an energy guy, to look at this and say, oh, well, if I steal this from here and that from there and that from there, I can not only cut energy, but I can also cut cost. So in the design, we're doing the process a different way. And then in construction, this is where the rubber meets the road for making these buildings actually function. And that is commissioning our building systems and envelopes to the point where we can be guaranteed that our buildings are going to function, because if the physics are right and the construction is right, there's no problem. It's going to work. So let's talk about delivery, because I think that's an important thing. Design, bid, build is our traditional delivery. It wasn't our traditional delivery until the mid-1800s and the late 1800s, when the AIA convinced the federal government to change the procurement rules, so you no longer had to procure design and construction under one contract, but you could procure design under one contract, construction under another contract, and oh, by the way, for design, you get to pick whoever you want and spend as much money as you want, pick the most qualified, but for construction, you have to go with low bid, right? Most people don't realize the history of this, but we used to deliver everything as integrated delivery, and it was the AIA that actually changed that. And what do we have here? We have a typical arrangement. We have an owner. They got contracts with their own consultants, the architect, and then the contractor, and then we have the subconsultants and subcontractors. Everybody's got a bunch of contractors, a bunch of liabilities. Look, team build. Well, gosh, it looks exactly the same. What's the difference? No bid. I love it. As a contractor, I will tell you, team build I will do every single day, because I don't have to compete and try to figure out. You know, when you bid a project to someone as a contractor, you're basically being asked to lie, right? You can give an accurate bid or you can get a low bid. You can't do both. So it's how low can I give you a number that you'll still believe that I can do the job to get the ticket to the dance? Because every person that I ever talked to, we're not necessarily going to take the low bid. Well, that's true, but guess who gets asked the first ticket to the dance, right? Low bid comes into the door to negotiate. If they don't like him, they throw him out, they go to the next guy. So integrated project delivery, we have one contract that everybody is a party to. One point of responsibility. It's a different model. Now, like I say, I've been doing this my whole life. To me, it's not a different model, but to most project teams, it's a very different model. So let's look at our responsibilities. You know, we all look at this model and we go, well, that's pretty typical. You know, we have contracts that bind us all, and with every contract, you have to protect yourself, right? So we have multiple layers of protection between these different people, but that's not the only thing that can happen, is because contracts can go between different people. You know, owner can hire engineers, the engineers can, or the subcontractor can be hired directly by owners, all types of different contracts that can get let. And what ends up happening is you get these multiple layers of contracts, all that try to protect the individual person who's doing that work. So everybody is creating boundaries about themselves, and they are saying, I don't want to step out of this boundary because I might get burnt. I don't want to step out of this boundary, so I'm just going to operate right here. And I don't want to, as an architect, I don't want to tell you anything about your job because that might get me in trouble. In integrated project delivery, our contract goes to everybody. The entire project success is based on the performance of the entire team. So as an architect, all of a sudden, I care about what the mechanical system's doing, right? As a builder, I care about what the design engineer tells me I'm doing, right? So if the structural engineer is designing the structure so it's 3 times as effective as it could be, what kind of structural engineer is that? Anybody could do that. Structural engineer is someone who designs it so it's optimized for performance, not so that it covers his butt and costs the owner 3 times more. That's just one example. So here's how the AIA has instituted this, made it institutional in our contracts so that you cannot, even as an architect, you can't even take responsibility if you wanted to. It says in the contract between the owner and the architect that the architects will have no control over or responsibility for construction means, methods, techniques, sequence, procedures, yada, yada, yada. And then from the owner, same thing, right? It says that when shop drawings are approved, the architect's going to approve it for design intent. What does that mean? Oh, does it a pretty picture, right? The AIA has systematically taken the architecture professor lower common denominator till architects have virtually no control of their projects. Are there any architects in this audience here today? One. Yeah, one of the reasons I do design build is because I got tired of seeing my stuff get built by people who didn't care and then the stuff was built wrong, right? As architects, we have lost a lot of control over what goes on out in the field. If you talk to architects, they'll tell you that, but they don't want the liability either. So, what we do in integrated project delivery is we start with the owner's business case. That's the very beginning of anything that we do. Now, if it's a house, it's one thing, but for commercial, it's another. So we say, what are the numbers? What do we need to hit? What makes this project work? We then follow up with the architecture and engineering, the estimating and purchasing, the construction means and methods, project management, and lastly, commissioning and performance. A very important piece of high performance construction is to make sure that the building is monitored and that the mechanical systems and the other type of systems that you might have are all being maintained, because when you have a very low energy building, if it starts to go out of whack a little percentage every year, you don't notice that unless you have back data to look at. So the intersection of all those pieces is integrated project delivery. And that is a very successful way of delivering these high performance buildings. When you try to deliver high performance buildings in North America right now as a design bid build model, because it's not being done very often, you end up with kind of levels of fear being built into the prices till the prices get so high that it's very hard to deliver. So as Harry Truman said, the buck stops here, right? So the key is responsibility. And that is what people don't understand at a very visceral level, that if you're willing to take responsibility as an architect, as a builder, as a team member, and you're willing to follow through on that responsibility and say, yes, my compensation will be tied to the performance of this building, then all of a sudden you have a successful model for moving forward. But if you're giving lip service to design build or to integrated project delivery, but you still have contracts that protect each person and that create separation, you're going to end up not getting to the kind of the core of it, which is the cost-effective nature of this delivery. So in traditional project delivery, generally information and design is siloed, right? Meaning that the mechanical engineer is sitting here and they're going to make an assumption. I got so many watts per square foot of interior heat gain. Where'd that number come from? That's what I pulled out of ASHRAE. What does that mean? It means nothing, because who knows what that building really has, right? The electrical engineer is going to assume a certain thing. The architectural designer is going to assume things. What ends up happening is you've got these layers and layers and layers of assumptions that are built into the process. And as you're building these layers of assumptions, you're not communicating between the different sub-trades and different sub-consultancies. And so you don't get the opportunity to look for symbioses and look for real information on how that building's really going to perform, so you're not able to really optimize the system. You're just doing the same thing over and over again. it's estimated by the Lean Construction Institute that 50% of a building is waste. Now, I don't really know that it is. I've read a lot of stuff that they claim it is, but I can tell you that a lot of a building is waste, that through our use of design build, we're able to deliver projects incredibly efficiently and affordably. And I can show you, and I will show you in a little bit, projects that we've done this with. So it's not just like I'm an academic guy talking, this is reality. So the problem is that we build these wastes into our costing, right? Because we do this, we were good at it. We've been doing this for 100 years of doing design bid build. So when we get our estimates, right, we get our estimates that already has all the numbers built into it. In fact, when you get a low bid, and most architects will tell a client to hold 10, 15, 20% contingency on the low bid. Why? Because they know it's bull. What a great way to start a contract, knowing that this has been underbid by 20%. Isn't that a great way to start a relationship with somebody you're trusting to build your new building? So by doing it the old standard way and not thinking forward, we are creating built-in waste, built-in inefficiency, and you're not going to deliver these cutting-edge buildings with the old model. So this is your typical construction project, right? I've got my architect, my structural engineer, mechanical engineer, my owner, my commissioning agent, my contractor. And what do you notice? Lots of chiefs, right? Do chiefs like to work together? Probably not very much, right? So we need to go from all these chiefs into the hive mind, right? Where all the information is central, that when one thinks it, the other knows it. So it's about information flow. That's basically what we're talking here on the most basic bottom level is information flow. When I talk to people about what we do in design build, and they say, well, you know, this contractor down here says he does design build, right? And that's true. But the reality is, if you look at our firm, we're the only one in our town, and we're a tiny little town, that does what we do. You walk into my firm, and I have a big open bullpen, and I've got architects, and I've got draftsmen, I've got estimators, and I got project managers, and I got superintendents, and everybody shares the same room, and the information is constantly flowing. During initial design, they're asking the estimator, they're asking the project manager. During construction, the architects are there. There's a free flow of information. The other contractor goes to his office, right? Calls up the architect works in his office, the engineer works in their office, and they're theoretically doing design build, but there's no information flow. They're still working in silos. That's what I mean about viscerally understanding what integrated project delivery really is, right? There's lip service and there's really doing it. So I like to think about it like this. I want to fly a plane. I've got 3 dimensions to fly a plane in. I want to take it off, I want to fly it around, I want to land it. And when I land it, I want it nice and smooth. I don't really want to do that, right? So we've got these kind of dimensions. We've got cost, we've got function, we've got aesthetics. Well, imagine if I had a guy sitting in his office with my cost lever, my roll lever, and a guy sitting in their office with the pitch, and then somebody in their office with a yaw. What's the chance of me landing that plane smoothly, right? It's the same concept here, guys. It's that, you know, if you're piloting the plane and there's information flow between you, it's going to be a lot easier if you're all in the same cockpit at least, right? So this is a pretty common graph. I don't know how many people have seen it before, but this is kind of your typical AIA standard way of doing business as an architectural project. You got pre-design, schematic, design development, construction docs, bidding, and construction. And this pink line is the cost of design changes, right? So how much it costs for an architect or the engineers to make changes. And this green line, which is inversely proportional, is our ability to impact the cost and function of that project, right? So they're inversely proportional. Way back here, for very little cost, I can make a huge impact. But up here, for a lot of effort, I can only make a little impact, right? So this is where design bid build establishes a hard cost, right there, right? Absolute worst place I could think of doing it. And this is why we end up getting out of every bid project a value engineering phase, right? What is value engineering? Value engineering is what goes on in a bid project where they take all the good stuff that the owner really wanted that's easy to snip out without changing all the documents and get rid of them, right? So my hardwood floors become carpet, and my high performance windows becomes crappy windows, and my nice exterior finish becomes something that's inexpensive. And we cut 10% out of the project, but we cut all the fake stuff out. We didn't really deal with the guts of the project where we could have really value engineered it. In team build, if you're lucky, you get a hard contract here at 10% or so into construction documents. Some team build gets out here into the end of construction documents. So you can see team build is a little better. You can adjust that a little better. In integrated project delivery, you're typically locking your contract in at about 30% design development. Why? Because you control the information. You don't need complete set of documents to be able to tell what that end goal is going to be. That's the lean construction principle being applied to being able to make your final decisions at the last moment. So you carry a contingency. You may be looking at 4 different structural systems for the same building, and you were actually hard pricing it back here in schematic and design development, so you're able to analyze those systems in relation to everything else, the mechanical systems, the lighting package, the daylighting, whatever it might be, and you're able to come through and say, you know, this is the optimized building envelope. This is the optimized mechanical system. This is the way we deliver this building. Now there's a last way of contracting, which is actually called relational contracting, which is what kind of we do, which is this: we're developing our hard pricing back here in schematic design. We get 30% into schematics and we can sign a final contract. But that's a little different model because the owner is integrally involved in everything we do with that. So let's talk about getting back to Passivhaus now, okay? Because I've kind of gone down the delivery, and I hope you guys understand that the reason I spend so much time in delivery is because when we talk about Passivhaus, we're talking about things that are, it's just a different way of delivery. It's a different way of construction. It's a different way of looking at the same product by creating a different process of looking at it holistically. And in order to look at it holistically, you need to be able to conceive it holistically from all points of view. That's why we need that integrated development. But the nice thing about commercial buildings, when you combine passive building and IPD methodology, all of a sudden you got a lot of advantages, right? So the building form itself is wonderful, right? Because commercial buildings are big. They generally tend to be big. So in terms of skin to volume, they have lots of volume and not too much skin. And since this is a fabric first approach, right, the reduction in the energy use comes through the skin. There's less skin, there's less money. And by reducing the skin, we're increasing our skin's performance, we're reducing our mechanical system size significantly, 70% or more. All of a sudden, that really expensive mechanical system more than pays for our inexpensive pink insulation, right? Right. The other thing that works in our favor in office buildings is that the function of, well, not just offices, but any commercial building, but the functions of these buildings are different than residential buildings in that they have a lot of interior heat gains. So we're able to take advantage of that. The other thing is that a lot of our buildings are operated very consistently, so they're easy to predict what kind of energy use they're going to have, so you can count on it. And so the key here in the residential market, because the residential is not as hard, is that, it's not as easy because, as I said earlier, the residential model of single-family homes, which we have here, is the worst thing that we can do for Passivhaus because it's a small volume for a big envelope, is to create market simplification and scale of our market. In commercial buildings, I can deliver these today at market rate all day long. There didn't have to be an argument about it. I can just do it if all I need is a client. Residential, I still can't do it because we're not at scale yet. So the keys to that are simplification, market scale, and I will show you what we have been able to do though. So our design build firm, we've consistently demonstrated market rate solutions for both commercial and residential. Now this home is in December of this month, where this home will be featured in Fine Home Building magazine as an example of an affordable Passivhaus. We entered this also in a Green Home of the Year contest 6 months ago, and we found out 3 weeks ago that we are nominated as a finalist. So Green Builder magazine is going to have this. I don't know if we won it yet or not. All I know is that the house will be in the magazine, and we may have won some category. I hope so. So this is so what. And if you read the Fine Home Building article, you'll see how we developed our system to get to cost effectiveness. But basically what we based it on was that most American families have a mortgage that they pay on a monthly basis and an energy bill, okay? If you pay that monthly amount, that net or that gross monthly amount of those two, and that stays the same, right? You could ask yourself, would I rather pay for electrons, right, that you use and they go away, or would I rather build equity in my house, right? If the monthly payment is the same, simple choice, right? We've been able to move 90% of our projects over to Passivhaus, and we don't even talk about, when they come in and we talk about Passivhaus with them, we say, look, this is our residential customers. We say, look, we'll design the house how you want. So here's your bucket of money. Here's your budget, 100,000, 300,000, a million, whatever it is. Here's the budget for the house. We're going to design for that budget, right? We're not going to talk about Passivhaus. But at the end, we're going to give you two prices. We're going to give you the price for the standard, and this is your monthly energy bill. And this is your Passivhaus, and this is what your monthly energy bill is. And if we can, if that $70 savings, let's say on this house, it was, I forget how much per month did this house save, 60 or 70 bucks. But if that'll pay for your offset in your mortgage, would you not want to do that over and above your mortgage? Absolutely. And that's been pretty consistent through our clients. So it represents right now a premium of anywhere 6 to 8% on the cost of the house. So in a commercial building, I can deliver it for same cost or less. In a house, we still haven't gotten there. We're still dealing with lack of industry scale. It's a no-brainer. So here's an example of commercial. This is the Center for Energy Efficient Design. This is LEED Platinum. It's also the first Passivhaus public school project in the U.S. that was certified, the only one. And it's also been certified in Europe. I hold my Passivhaus designation as both North American and European. And I certify with both institutes. And did you do that? So this was a project that was really near and dear to my heart because the idea here, this is a local school district to me. It's the next county over. And these guys came up with this idea. They wanted a building that teaches sustainable concepts, and they wanted a building that they could underpin their standards of learning in Franklin County, Virginia, with these sustainable concepts, meaning that when these kids have to learn by SOLs, you guys probably have something similar here, like that all the kids got to learn basic stuff. So like in 6th grade when they're learning math and they're learning percentages, right? Rather than Janie has 5 apples and Jimmy has 6 apples and what percentage, yada, yada, we say, well, on the Center for Energy Efficient Design, we have a 1 kilowatt PV system that's fixed, and we have a 1 kilowatt PV system that is tracking, and go on the website and look at the data over the last week, and then look at how much energy and how much percentage better is one than the other. So they learn their basic math, but they're learning sustainable ideas. And they've got over 70 different things written from kindergarten through 12, from recycling all the way through physics. It's pretty cool, right? My company donated $160,000 to this project, and that was back in 2008 when we still had money before the building depression. But then we went out and raised another $100,000, right? And we got a commitment, and then we had $400,000 in grants. So we basically went to the school board and said, we're going to build you a state-of-the-art building, and all you have to do is put up $400,000 for a $1 million building. So that was a pretty easy sale. But what happened was this started out as an underground building, as an earth-sheltered building, because that was my go-to strategy. Malcolm Wells, remember Malcolm Wells? That was my thing. I knew I could save 50%, 40, 50% energy by going to earth-sheltered. And that's how this was originally designed. But then I started doing Passivhaus in 2009. And I started thinking, man, I wonder if I could save even more energy. So I went to the superintendent and I said, hey, I've got this idea about doing a Passivhaus building, and maybe I could save even more energy. And his thing was, he had no idea what I was talking about, really, honestly, and I'm kind of lucky about that. But he basically said, well, if you can save more energy, great. It just can't cost a penny more than what we've already got approved, right? So we ended up, I did all my analysis, went back. First thing I found blew my mind was that my earth-sheltered strategy was only good for 50%. No wonder I could never get past it, because the Earth's an unending sponge of energy sucking. And so, so I had to unearth shelter this thing. But I ended up, when I went back to him, I said, well, I can save 25% more energy, and it's only going to cost you $26,000 less. And he was like, wow, sign me up. So we did that. And that building has performed tremendously well this has just celebrated its 3rd birthday. This is the Malcolm Rosenberg Center for Jewish Life. This was the first assembly building built to Passivhaus standards in the U.S. It also is a first in the world building that has a commercial kitchen hood within the Passivhaus envelope. Okay, now this is an interesting story because when I started the design work on this, I said to myself, well, this is going to be, it's going to have a kitchen. Even worse, it's going to have a kosher kitchen, so it's going to have two hoods, right, because it can't mix anything. And I said, well, let me see, how do I do, because the air tightness, right, and you got this big, huge hood going, whoo, sucking all this air. So I said, well, I got to figure this out. And I couldn't find anything online about it or any kind of information. But I looked and I saw a couple of schools in Germany. And I said, well, they have hoods, right? They have hoods. So I said, well, if the Germans can do it, I can do it for sure. So I committed to doing this. I had no idea exactly how I was going to do it all. Then I'm at an international conference several years ago, and I was meeting with one of the Passivhaus folks, the Institute folks, and I said, so how do you guys do your hoods? You know, what do you use for air tightness? Oh, no, we always put it outside the envelope. I said, oh, you're kidding me. He goes, oh, no, we never put it in the envelope. I was like, oh, man. So, and then I had to explain to him how it took me 3 months to find a UL-listed damper that I could use on the hood and all the stuff we went through. But what was really cool was I felt like I'd been going over to Europe and just, you know, like trying, kind of like with Achilles when I asked 200 questions, you should see me on one of those European project tours. I mean, I had 1,000 questions on them. You know, how do you do that? Because it's like the only place I can get my information. But the really cool thing is they actually got in touch with me after that, like a few months later, and said, we're doing a school, we want to put it in the envelope, how did you do it? And so I felt like, hey, I finally got to give something back. But this building right here, 8,000 square foot, sanctuary, multi-purpose rooms, kitchens, office, conference room, $135 a square foot. They're paying a little over $300 a month in energy on an 8,000 square foot building. This is Hickory Hall. This is, right now, it's the largest building built to Passivhaus standards. It was built as a modular dormitory. This building over here is Elm Hall. It was completed in 2010. It's also modular, concrete foundation, 3 stories of modular wood, brick veneer, you know, ugly, typical Southern Virginia colonial architecture. And so this is the second building on that quad. So they had to match, right? They had to match exactly. I mean, it had to match, the windows had to match, the brick had to match, everything had to match. Even the construction technique. Concrete foundation, 3 floors of wood, same kind of veneer. But here's the cool part. This was delivered in 2010 for $125 a square foot. This was delivered in 2012 for $118.75 a square foot, or $118.25, $575 per square foot less. 60% energy savings over that one, which was Energy Star. And the really cool part is if you do the math on ROI, it's infinite. It costs less. It's an infinite rate of return. So this is also really neat. This was what they call a prototype building. So for Passivhaus, because of the low energy demand for primary energy, right, there's only 3 metrics. Remember, heating and cooling demand, primary energy, and air tightness. That's it. Well, on a building like this, that's a commercial building that has a high process load, there's no way you're going to meet that primary energy. You know, you're not going to get that low. It's just not going to happen. And they recognize that in the Passivhaus movement, and so they do what's called a prototype building. So every time, they've done grocery stores, they've done laboratories, they've done medical clinics. Every time they do a new building type, they do a prototype. And that sets the benchmark for the next one, which has to meet that or go lower. They had never done a dental clinic, so I worked with the Institute in Germany to do this as a prototype building. Really cool experience. Working with German building scientists is an eye-opener for an American because, boy, are they precise. It's like 20 comments. You answer all 20 comments. 8 questions about the 20 comments, and then 14 more comments. You know, so but it did make the project much better at the end of the day. But this dental clinic is one of our specialties in our firm is dental clinics. We have done 10, or in the last 10 years, we've done 12 clinics. So we know dental clinics, right? First thing that dentists ask me, how much does it cost for a dental clinic? I tell them, well, not including your site and site development, not including your dental equipment, but everything else between $150 and $200 a square foot. We know this, right? We've done enough of them that we know it. This is a Passivhaus dental clinic. It was delivered for $155 a square foot, low market rate. Here's the cool part. They're paying $325 a month in energy. I know that a 5,000 square foot dental clinic typically can run $1,100 or $1,200 a month, so they're saving lots of money. The dentist that was not what they were excited about. When I went and said, hey, what do you think? You know, because we're not quite a year old, so I've got 10 months data on this so far, but we know where we're sitting. They say, oh, the $700 a month, yeah, whatever. It doesn't smell like a dental clinic, right? That's what they're so excited about. Like the one dentist said, yeah, I did a dry socket today, which is an infected tooth. He said, the guy in my old dental office, my operatory would smell all day. He said, by the time the guy left, my operatory was clear. So, and I've had several people come visit me. They walk in, first thing they say is, it doesn't smell like a dental office. Why? Because I got 100% fresh air going in this thing all the time. So here's some more examples. These are examples of other design builders around the country delivering Passivhaus. Tim McDonald in Onion Flats, this is in Philly. Anybody here going to Greenbuild, I think you'll be able to see this. This is a Passivhaus zero energy duplex, triplex, 129 a square foot, all in, including renewables. I love Tim, this is Tim's saying, zero energy, zero premium, zero debate, right? Why does this work? Tim's an architect, his brother's a builder, they're partners, design build, once again. Alan Gibson and Matt O'Malley at GoLogic, they're doing the same thing. This is a co-housing development in Maine, 35 units, delivered for $135 a square foot. This is a zero energy home in Maine, also by Alan, $176 a square foot, including the renewables, including the solar thermal and the solar PV. And you notice something about the PV? These buildings sip energy. We did a calculation on a 2,000 square foot house. For me to go in Virginia, for me to go and build a 2,000 square foot house and get to net zero, it cost me 60 grand in PV. If I build a passive house, it cost me about $18,000 for the passive house, and then my PV system is about 20 grand. So net, I'm about $20,000 cheaper if net zero is what I'm shooting for. Remember, we learned this back in the 70s. You conserve first, produce second. This is Unity College, pretty fancy little dorm that Alan did in Maine, $207 a square foot, including the solar thermal. And this guy is my hero. This is my builder hero. This guy's name is Thorsten Schlupp. He's up in Alaska, 14,500 heating degree days, zero energy home. Zero energy home, passive house. If it can be built there, it can be built anywhere. $234 a square foot, including renewables, and a 20,000 gallon insulated water tank under the house that he charges with the solar thermal panels all year and flywheels them. Last year, he burned less than a quart of wood to heat this house because the 20,000 gallons created a flywheel effect, and he was able to draw that heat off over the course of the year or the winter. Here's the cool part. Guess what? In Alaska in the wintertime, you don't have any light, and these windows, even these quad glazed Arctic windows, not robust enough. He had to create these R40 thermal shutters to be able to get the heat loss. See look at when he's got the thermal shutter, what a difference. This one is his latest project. This is a zero energy home, $205 a square foot, delivered. Passive house in Alaska. Why? Design build. He controls all the levers. So lastly, Dr. Feist, who's our kind of the founder of the modern passive house movement, said this at a conference about 5 years ago, and I think it's just brilliant. I wrote it down when he said it. Investing in value instead of energy consumption requires little financial efforts, but rather creativity and intelligent solutions. That is, I mean, he said that, and I was just like, yeah, you know, I mean, this is just the way. I've got this plastered all over my office, because he's right. I mean, it doesn't require heroic financial maneuvers. It just requires somebody to be clever. Thank you for watching this presentation hosted by Owens Corning. Once again, I'm Adam Cohen, and if you have any questions, you can email me and ask me. I will be happy to answer. And thank you, and have a nice day.